Great, thank you. Hi, everyone. My name is Luigi Marini. I'm a research software engineer at NCSA and part of this NSF-funded project called the Permafrost Discovery Gateway, which is a collaboration among lots of institutions, both here in the US and in Europe. We are somewhat fairly new to FuncX and Parcel, and so this talk will be more of a overview of the project, the requirements, and how we plan on using FuncX and Parcel. So if you're not familiar with the permafrost layer, this is a top layer of the soil that is frozen all year round, and it's present both at the Arctic and Antarctic. And recently, it has been changing rapidly. And so the goal of the Permafrost Discovery Gateway is to set up an environment to monitor these changes at a global scale, at the Arctic and Antarctic scale. This has a lot of impact, also human direct impact, in areas where, you find humans, but obviously the climate in general. So our goal here is to create both pipelines as well as interactive web interfaces to deal with these data products that we're trying to create. And all these data products are based on remote sensing data sets, which are fairly large. And then for the most part, a lot of the compute and algorithms, the models that we're developing are mostly machine learning models. But there's also a big emphasis on the visualization of these data products. So here's an example of one of the models. So this is a model developed by Chandi Vitharana, University of Connecticut and his team. And it's an RCNN model that tries to identify ice wedge polygons, again, at a global scale. And these are basically polygons that water gets into the ground and it expands, and now they're melting. And so they can do this by looking at remote sensing images. You can see on the right kind of how far they've gotten so far as part of this project. This is actually out of date. They've gone farther, but data size is obviously one of the concerns here. And so if you look at it for this particular model, and the Permafrost Discovery Gateway is looking, is developing several of these kind of models, we're using the Arctic DEM data set. And this gives you just a little bit of a sense of the scale of it. So this is 0.5 meter resolution data, about 4 petabytes of imagery, 1 million images. And obviously, these models are optimized for GPUs. So what we do at NCSA as part of this project is we're building the interfaces, the science gateways kind of aspect to kind of launch this job, monitor them, and not just manage the long learning pipelines, but also the interactive kind of, being able to launch these jobs interactively, these tools interactively, as well as new tools that can be developed. So one of the tools that we use is this Clouder framework that we use for both the data management as well as launching the jobs. For the PDG, we're running Clouder on a Kubernetes cluster at NCSA. It's just an OpenStack cluster called Radiant, and then we run Kubernetes on top of it. And right now, what we're doing is a very traditional kind of SSH tunnel, HPC Slurm submission of this code right now on Bridges 2, Exceed Bridges 2, before the model was trained on Frontera. And so one of the things that we want to do is we want to leverage FuncX in this case, ideally, for this submission to make the models and similar models more portable, because our solution right now, it's very, very specific to bridges, right? And so that's, one of the things. One of the questions that I had, and this, again, I'm very new to FuncX and Parcel, is this idea of, I know that a lot of these resources kind of frown upon running long-running not jobs, but processes on the head node. And so, how do people manage this? So, because we want to do this in a streaming fashion, right? As data comes in and becomes available, we want to make more submissions. And so, can we run FuncX on the head node of Bridges 2, 24/7, and then just call it whenever we need to? So the other big aspect of it, and this is where we've done a little bit more work on this, is the idea of visualizing the outputs of these models. And so we're building some systems for visualizing all this data, at the Arctic level, And so this is a lot of data, and our colleagues at the Arctic Data Center are leveraging something called cesium, who can do 3D tiles, which means that you don't just have lat long, you also have altitude, which is kind of interesting. So that as the products come in, we can, the users can zoom in and zoom out, which at this scale, is, somewhat problematic, or it's challenging. And so here's an example of the output of Maple that you can see, right, overlaid, and there's a lot of these polygons. The way this is being, this pipeline is being developed is with the ideas of tiles, to creating these tiles. And the big challenge that we have, and this is probably, you're very aware of this, it's very typical, like Google Map and other GIS applications. But the challenge here for us is that the data that is coming in doesn't match the tiles that we want to create. And so we're streaming the data in, and we're creating all these tiles at different levels. And so we need to have something that keeps track of requirements, saying, okay, now I have enough of the input data to create a specific tile at a specific zoom level. And so one of the questions for you guys is, are there typical patterns that people have used for these kind of things, where there is a set of requirements to then launch parcel jobs when we have enough accumulation of data? Because right now we're looking at doing that our own way, and developing it our own way, and we don't want to have to wait for all the data to become available, because these jobs run for a long time. And so what we're working on right now and developing is the spatial index, which is kind of like our requirements, and then this tile task dispatcher, which just monitors this and eventually says, okay, I've got enough data to do a particular section of the Arctic, and this is where we're planning on using Parcel primarily. And then because of the zoom levels requirements, we want at high resolution raster data, and at low resolution, when you're zoomed out, 3D kind of shape files, right? And so we have these two tile builders that are slightly different. And we're also looking at how we can use Parcel to potentially scale out that aspect of the workflow. Finally, I mentioned Cloudera at the beginning. So we're, Cloudera runs on Kubernetes, and we want to launch directly from Cloudera. And we have this concept of extractors, which run as containers. And so we've done some work already in launching Parcel jobs on the cloud resources on the Kubernetes cluster from the Cloudera extractor specific to this use case. But we want to generalize this and make it simple enough as we do with other simple Cloudera extractors, so that somebody who comes in and says, okay, I want to use Parcel to do this particular computation on Kubernetes, that they don't have to worry too much about the configuration of it. And one small improvement request would be that so far when we're working with the Kubernetes Parcel provider, we had to provide the kubeconfig, and there's a way to actually just let it use the kubeconfig of the cluster you're on, because that's our use case. So if there were a simple way to just let it do this, it would make it a lot easier to deploy both for this project, but for other projects as well. So looking forward to learn more about both FuncX and Parcel today, and thank you for having questions.
So you asked about if there's any patterns for dealing with starting tiles as the data becomes available. I can talk offline with you about some stuff I've done which sounds kind of related, which is where we were generating data over one tiling, and then we had subsequent jobs which used a different tiling. So we wanted the second tiling jobs to launch as the first, as the appropriate first tilings completed. Maybe we should talk about that offline because it's a bit complicated.
That would be wonderful. Thank you, Ben.
Yeah.
But we also see the same type of requirement in Matthew's work with the brain imaging stuff as well. So I think between cosmology with this, with that imaging work, I think it's a fairly common pattern. So maybe if there's a way, Ben, that we could sort of write up, here's how you attack this type of problem, or here's a few examples, and people can adopt them for their needs. Matthew might have thoughts as well here. If he's, I think Matthew's here because he just messaged me.
Yeah, that slide you presented with like the subsets of tiles from an array, I've sent that to Kyle and was like, can Parcel do this? Can I establish dependency? Yeah, exactly. I created, yeah, Yadu, do you remember? I created like the exact same thing and was like,
it's the same thing.
Can Parcel do this? And you said you tried and it's really hard. But we should keep trying is what I was gonna say.
Well, maybe we can solve it together. That would be great.
Yeah.
Thank you.